That's the 15-inch air, right?
Yes.
Yeah, same as mine. It's just the dark color one.
Right. This looks bigger somehow. It's M2, right? This mine is M2.
Yeah.
M2.
Yeah, you're right. It does look. It's really weird.
Maybe it's just optical.
Oh wait, this is the 15-inch air, right?
Yes.
Yeah. Why does it look bigger?
It's color.
Color. Yeah. I love this machine.
Yeah, me too. It's. I mean, unless you're doing some heavy AI inference.
Yeah. Sylvia's getting a new machine when I get home. She has a 2014 iMac.
Okay.
And it doesn't get software updates. So I'm betting on the new Mac Mini.
Yeah.
It's a great machine. We'll get started in a minute or so. I have to mute this. Hang on. Or I'm gonna get feedback.
Okay. That's okay. All right. Welcome, everybody. This is ICNRG. Thanks very much for coming over. We are Dave Oran, and my name is Dirk Kutscher. And
We are into our 12th year.
I think so, right. And let's see what we can achieve today. So just quickly, as you probably are aware, but we want to remind you, we are following the IETF IPR rules. So you are expected to notify us of any IPR that you think you contribute or that you discover in the discussions here. These meetings are, as always, recorded. If you want to ask questions or make comments, please use the on-site tool for queue management. And yeah, just be aware that everything is recorded and will also be made public at some point. Just quick reminder, we are within the Internet Research Task Force. We're not setting any form of standards. So ICNRG is one of the groups that is actually doing, has published quite many RFCs. So these are all either experimental or informational RFCs. So our goal is here to, for example, develop specifications that enable people to do experiments that help research and help us learning more about ICN concepts, potential deployment challenges, and so on. And yeah, we have the usual infrastructure. If you haven't signed up for the mailing list, please do so. And today we have one volunteer already for taking notes. Thanks very much, Rio. Is there anybody else who is interested in helping Rio? Ah, that's great. Thanks, Rod. So in that case, maybe use the note-taking tool that you can work on the same document.
The note-taking tool from the data tracker?
Yes, yes. Great. Thanks very much, both Rod and Rio. And
will the entangled state of the two note takers automatically collapse if we go to publish the minutes?
I doubt enough of the people in the room get that context.
All right.
No, Rod runs the Quantum Internet Research Group. That's why.
And yeah, we have a pretty full agenda with interesting talks today. So thanks everybody who contributed their work. And so we talk about Flick first, and then CCNX content object chunking. And then we have an update on reflexive forwarding based on some recent development. And then Jungha is talking about ICN challenges for metaverse platform interop. And then we have Aijun Wang talking about distributed microservice communication. before we get into that, just quickly, so we have a couple of active drafts. So yeah, thanks everybody who keeps working on this and who keep submitting new work. So the Metaverse Interop draft by Jungha and colleagues, Flick, of course, content object chunking and reflexive forwarding. And there's also a flow balance draft by Dave. So Flick is one of the, let's say, core specifications that we want to get published relatively soon. So that's why, yeah, we are grateful that Mark could spend some time on this and is going to talk about the updates today. So we said this many times, so this is kind of really important technology, and we really encourage people to have a closer look and help with finalizing this work. And without any further ado, I think we can just start directly with Flick, unless there's any other suggestion, any agenda bashing request. Okay, so I bring up Mark's slides.
Hello, Mark.
Good
Hello.
morning. Good morning. Good morning.
Early morning for Mark.
It is. It is. 5 a.m. But that's okay. I get to go have breakfast after this. So, all right. This is the most recent update on the Flick draft. Can I drive these or?
Yeah, let me try to find you and hand over the control. You got it.
Okay, there we go. All right. So, as usual, I give the super quick update about what Flick is in case there's anyone new, and then I'll go over the differences since 05 and talk about the effort to implement the 06 draft. So Flick is a manifest, so it lists the content object hashes of the objects that make up the user data. And it also has a way of telling the client how to generate the names that go with those hashes. So you can get the complete name of the object and request things by hash, which is the most secure way of doing it. So this lets you offload security signing to just the very first thing in the manifest. Manifests are hierarchical, and there's a canonical traversal order. We also support encryption. There's a basic symmetric encryption and a way of doing RSA key wrapping. Okay, so that's my super quick update. If you have any questions, you can email me and we can go over it in more detail if you'd like. So name constructors, there was a name constructor called a hashed schema that was used in the text, but it was never defined in the ABNF, so I defined it in the ABNF. This is the default constructor that CCNX used because it's the most space efficient. The ABNF did not define the pen, which is part of a vendor TLV to identify the vendor. So I added the pen definition to the ABNF. So the other RFCs that use AES, GCM, and CCM, which are two of the encryption modes, recommend having an out-of-band salt to then use with the nonce that's carried in the data. So I refactored the text had been there for quite a while saying you should do what these things say, but the ABNF didn't follow that. So the ABNF was updated, and some of the text was updated to make clear that when you negotiate a key ID for a symmetric key, you should also negotiate the 4-byte salt to go with it. The salt is not mandatory, but it's the recommended way of doing it. And there was an error that I did 4-star octet instead of just 4 octet for the salt. That needs to be fixed in an 07 draft. there is a field called Start Segment ID. So if you're using segmented names or chunked names, you need to know the beginning chunk number for each manifest and for each object in the manifest. Previously, the consumer just had to remember it all as it traversed the tree. This new optional field just says this is the starting segment number for this manifest, so you don't need to maintain state between manifests. So this is kind of the preferred way of doing it nowadays. It just makes decoding much easier. All right, so that was all of the updates. So they're all fairly minor little tweaks, and these have been based on updating the implementation of Flick for the 06 draft. So I'll probably find a few more little things here and there as I go through the implementation. There's been a Python implementation of CCN client and an old Flick, maybe like an 02 or an 03 draft of Flick before we had name constructors. So the main effort right now is updating this for the name constructors. Because it wasn't really structured for that before. It only supported hash-based naming. So this is taking me a little while, but it should be done in the countable number of weeks from now. What else was there? So I'm using C4 as the reference forwarder. I've been working with Hitoshi on a few other things, so that this was kind of an easy way to go with that. C4 doesn't support nameless objects, so I can't actually test it with the current implementation of CCNPy because that only supports nameless. So there's a little bit of a impedance mismatch there. But once I get the segmented schema name constructor done, then it should work with C4. And the next steps. So after this external implementation is done, we should be able to finalize the draft. And then I might get around to doing a native implementation in C4, maybe a simpler implementation without all the bells and whistles. And also see if it's possible to do nameless objects in C4, as that would make the hash-based schema work with it. The segmented schema does use chunk-based names, which it would be another reason that we've introduced this chunking draft, which is the next thing on the agenda. So yeah, so the finalization should be impending, and we should have the implementation caught up with the draft very soon. So, any questions? I'm not hearing you.
This work's been going on for quite a long time, and we'd like to wrap it up because it is a core specification for a full, really capable ICN system. So I think what might make sense is let Mark finish and test the current implementation work on C4, and depending on what that does to change anything in the spec, we'll go to last call at that point. Would anybody object to that plan? Going once, going twice. Lovely, excellent. So that's the plan. We'll make sure to post on the list progress on the implementation and the current status. We may have to do an 07, to fix things up. Now, please review this draft. The sooner we get comments in from people, we're interested in not just the technical validation, but the understandability of the spec, since it's pretty important for anybody writing applications on top of the current protocol implementations, and then we'll try to move it forward and get this closed up. So thank you. Shall we just segue into chunking?
No,
or
Hitoshi is in the queue.
Hitoshi one. Hitoshi.
Yeah, Hitoshi. So actually, currently C4 doesn't care or doesn't implement nameless object, as you said, and because we have not found the very specific use case for using nameless objects. So that's why we don't care so much about the nameless object. And it's really great that you will implement it in a C4. It's really great. Thank you so much. But the question is that if there is no nameless object implementation in for the side, is it a huge problem, or is it also possible to use Flick without using a nameless object?
Yes. So, so maybe you and I can talk about nameless objects, offline, because there are some great use cases for it, and this, just in storage size and reusability of the objects. But I know that the nameless objects worked with the old Metis implementation, and I've verified the objects, just kind of looking at the wire format of it. So I'm not really that worried about the hash schema working without testing that in C4. The thing that I would be testing in C4 is what's called the segmented schema, which uses every object has a unique name, and they just use a sequence number to indicate their serial order. So that should be all copaesthetic objects with proper names and unique names.
Okay, thank you.
So, Mark, that actually brings up some history here, since nobody's revisited this issue probably for at least 5 years. Maybe you and I could get together and write something up about what nameless objects are all about over again, and explain the use cases, because some of them are pretty powerful, right?
Yes. Yeah.
All right,
Yeah. So not only being super compact, just the ability to like move data between locations and change locators, and it's very powerful.
And also host data on in sites that don't trust each other.
Yep.
Right.
Mm-hmm.
And aren't willing to agree on a single name for things. So
yeah.
Okay. Let's take that offline. You and I can work on something over the next month or two.
Okay.
So Mark, quickly, so the C4 Flick implementation is obviously work in progress. Do you plan to make this available at some point? What's the current status of it?
Oh yeah. So if I were to do any work in C4, I would do merge requests into the main C4 branch.
Okay.
Okay. The CCN Pi implementation, it's a pure Python CCN client plus Flick, so I can just run that against a forwarder. So that doesn't involve any changes to C4 code.
Okay, yeah, that's good to know. Right, thanks. Okay, let's move on. And here we go. Okay, let's talk about CCNX chunking.
Okay. All right. So this Hitoshi had approached me and said, "Hey, do you have anything on doing chunked or segmented names in CCN?" And I said, "Yeah, we have this old draft." So this is basically bringing up an old draft, because there's some demand for getting how to do this standardized. So I'll give a brief history of chunking and segmentation, then some examples about how this draft says to do it, and then go over the specific proposal that's in the text. So ever since way back when in the original CCNX, there was a way to do what they called segmentation, which was basically to put one of these command markers, %00, for example, with a sequence number in it, and then you could match that sequence number to this thing called final block ID. If they were equal, you were at the last segment. But it was done kind of like a tape protocol where you could then just write more data after the final block ID, and you could go further and delete, and it was complicated. And there's an email from the NDN mailing list where I went over my understanding of a lot of the ins and outs based on a discussion with Michael Plass from like way back when. So in 2015, with the CCNX 1.0 work, we came up with this draft to come up with a simpler segmentation protocol. We renamed it chunking instead of segmentation to clearly differentiate it from the previous, but we never brought it up as a research group document. We just did a few drafts and then it kind of died back then. All right. So the usage is you take a single object, you break it up into chunks that are contiguous byte ranges of content object payloads, and you put a sequence number in the name to identify it, and so you can retrieve it based on, you know, those sequential names. There is a final chunk ID field, and when that field is equal to the chunk ID that's in the name, you're at the last chunk. It's very much like the old segmentation, except we don't allow you to just add more data later. So you can have an object that's a single chunk. So here the final chunk ID equals the chunk ID in the name component, has some payload, and then it has, you know, the validations and signatures. You could have a 3-chunk object. So again, you know, chunks 0, 1, and 2. You always start at 0. So in this case, the draft as it's stated right now says all chunks have to have the same payload size except the last chunk. So this allows you to seek. So you get the first chunk, you say, oh, they're using 1100 byte payload. So I could figure out where to jump to if I wanted to seek. Because the validation algorithm can have some fairly large things in it, like the name of a key locator or two, or a certificate, or just embedding a whole certificate, that can be a significant number of bytes. So the draft allows you to have some preamble that has the, for example, cryptographic information or vendor information, and then you get into the chunks that have all the payload, and you don't need to repeat that key information anymore. So in summary, you know, you can have some preamble chunks, then you can have some payload chunks, and then to handle some error conditions, you can have padding chunks at the end. So like in this example, I started out and I thought my last chunk would be 4, but when I've gotten to 4, I thought that there was more data, so I said the end is 7. But then something happens and the end is really 6. So in chunk 6, I say the final chunk ID is 6, and then I pad out those missing chunks. So if someone tries to retrieve a 7, they'll get a response back saying the end was really 6. And that way you won't get like timeouts for, you know, objects that don't exist. So these are the rules that are written. This is copied and pasted straight from the draft, so I don't need to, you know, really, you know, read it verbatim. But the rules are, you know, you have to have a chunk number in the name, and it starts at 0. It goes up by 1. Leading chunks, you know, can be these preamble chunks, and they don't have a payload. All the chunks with a payload have the same block size except the last chunk. And the end chunk number, you know, when that is, sorry, I called it end chunk numbers, and I think it's end chunk ID, you know, has to be the same as the chunk number name. That's the last chunk. And, you know, you can provide these end chunk ID hints as you go, but you shouldn't decrease them. And if you do decrease them, you should pad it out so someone who's pipelining requests, doesn't get into timeout conditions. So the only thing that I would change is this requirement that you use equal size chunks seems overly restrictive. I would make that optional. So, like if you put a chunk size field in there, you're guaranteeing that you did that. Otherwise, I would say just use any chunk size as long as they're contiguous bytes. And there's a question.
Yeah, 1 second.
Hi, Rob Van Meter, KOI University. So in your slides, I think you said something about this a minute ago, but it seems like you have chunk ID, chunk number, end chunk, final chunk ID. Is this, I haven't looked at the draft yet. Is the draft internally consistent and the slides just not consistent, or are these actual separate concepts here? Or is it just
Right.
the history is doing this in?
Yeah. So it should be chunk ID and final chunk ID. And here on this slide, it is saying chunk number and final chunk number. So since this was cut and paste directly from the draft, it seems like the draft has an inconsistency in it. So we'll need to, they shouldn't be different.
Okay. And then on the fixed chunk size thing, personally, I'm a little dubious that changing it to variable size is going to gain you something that's going to be worth the headache on it, just from long experience of having worked in file systems decades ago. It's just sort of a gut feeling,
right.
though.
Yeah. The main reason for making it non-mandatory is if there are other fields you want to put in at some point that have some other metadata, you'd have to subtract that out from every content object to reserve space for it in the so your payload didn't overflow. So that's my main concern about making it mandatory, is you then have to reserve space for anything you might do down the stream, so it doesn't overflow the MTU, for example.
So I guess I'm in the queue. So two things. One is I would like to see some experimentation with somebody trying to use a variable chunk size before we either prohibit it or add it generally to the spec. So let's get a use case that needs it before we put it in, right? We're not trying to standardize here, right? These are experimental
Right,
drafts.
yeah.
We're supposed to experiment. We're not trying to lock something in for all time. So I would say, don't put it in until somebody wants it, and then we can put it in, right?
Okay.
And then I had one other question. I don't believe we mandate that the chunk number name segment be the low order name segment of the name, and that divides into two questions. One, should it be? And second, what's the consequence if it isn't?
Right. Yeah. So the draft is written that the rightmost chunk ID is the operative field. So, I could have
you can't you might actually see a name with 3 chunk ID name segments in the name.
Yeah. For example, I have an object that's named with a chunk ID, and then I write some metadata about that. So I append more name components after that chunk ID, and then I have a new chunk ID, because I'm extending some previous name. So Yeah, so the draft is written that that is the rightmost chunk ID field is the operative field.
But the rightmost might still be not the lowest order name segment in the name. So are we mandating that the operative chunk ID be the low order name segment in the name?
Yeah, that's how it's written. Is the terminal sorry, not the terminal, but the rightmost chunk ID is the operative chunk ID, and anything else is just name.
Okay. All right. So let's make sure that's really clear, because it wasn't clear to me.
Okay.
All right. Some people might interpret things because of the way, again, file systems work and other things work, that you can't have trailing name segments at lower order below the chunk ID. And we're saying, I believe, that there's no reason not to. Right?
Right. Yeah. I'm not saying that it's a clever thing to do, but there have been examples in the past of basically extending names with, like, key locators or other sorts of metadata that talk about that named object.
Okay. So let's just be clear in the spec that we're not necessarily saying you have an invalid name if the chunk ID is not the last name segment in the name.
Okay, yeah. It should say the rightmost. It might be inconsistent again, but it should say the rightmost chunk ID is the operative chunk ID.
Okay, thank you.
All right.
Other questions?
There's like one or two more slides. So another question is why wouldn't you just use Flick, because these kind of do the same things? So yes, you should use Flick. That's a better way of retrieving data. But if you're using something like the segmented schema, which is what I'm going to be using with C4, basically all the names have chunk numbers in them. So these two things are in a way tied up, right? You basically chunk the data and then you write a manifest to refer to those chunks. So you don't need to put all the cryptographic information into those chunks, but they're basically all chunked names. And personally, I think removing the equal size requirement would be good for Flick, but I haven't gotten there yet, so I can't point to something specific yet. Right. Okay. Yeah. So we want to adopt this as an RG, and then update that to be a research document, and hopefully this should sail through relatively quickly. There's not a lot to it.
Okay, so we will do a adoption call on the list later today after the meeting, because this, no reason to delay on that.
Okay. All right. Those are my two. Thank you.
Thanks very much, Mark, for getting up and for reactivating this work.
All right.
Okay, thank you. So now moving on to reflexive forwarding. And so Hitoshi has recently done some great work in implementing reflexive forwarding and also helping to improve the draft. So today we'll do this in the following fashion. So Dave is going to do a quick recap of the concepts, and then Hitoshi is going to talk about the recent changes and some new ideas and challenges.
Hi. Am I on? Yes. Good. Great. So, we're going to tag team this. I'm going to give some of the background, and then Hitoshi will do the really important parts, which is what we're actually building and how it works, and what the protocol details involved in making all this work are. So this has been around for a while. The genesis, hello? There we go. The genesis is that the history of early ICN protocols were basically only for content retrieval. And what we've discovered over the years is that there are a bunch of applications that could really benefit from the concepts in information-centric networking that don't fall neatly into this, I ask for a piece of data and I get it back. So there's been a number of academic publications, one from Dirk and me and some other folks on how to do remote method invocation. And in the process of doing these things, we discovered a bunch of interesting things. And this work grew out of that. And to the extent we've been making progress on applications of ICN in non-content retrieval type of applications, we've seen more and more interest growing in enhancing the base protocols in order to deal with those sorts of things. So I'm going to do a really quick run through of sort of like why all this is happening by talking about the motivation for multi-way interactions that are more than just a request response interaction, why some of the existing approaches that have been tried in the past to do this aren't particularly attractive, and just the sort of like the first very top level overview of what design we're working on, and then Hitoshi will take over with the important parts. So the motivation is that there's scenarios where two-way handshakes just don't fit the bill. When we see things like RESTful communications for the web, any type of RPC interaction, and things like sensor networks and phone home scenarios where you want to be able to request that somebody send you some data in the opposite direction from the direction that the original request comes from. And lastly, anything that has an initialization procedure that requires two peers to synchronize their state before actually doing useful interactions. So there's some desirable features you'd like in this. One is the ability to push data, even though ICN-based protocols are fundamentally pull-based. And in order to have session-like communication where there is some state kept at both ends after each interaction, and you can leverage that state without being every request response being independent of every other one. And we'd like to do this in a very idiomatic way using the existing protocols. So we have remote method invocation, and things you would do with that are being able to fetch arguments from the client. You don't have to push the arguments in the initial request. You can use it to perform authorization, and also to have a separate interaction. The first one initiates a computation, and the second one returns the results. And it separates those two things so that the network state doesn't have to persist for the entire duration of a long computation. And then for sensors and actuators, you'd really like data to be fetched from the gateway rather than pushed from the device. A whole variety of reasons: power consumption, congestion control, and a whole variety of things. And eliminate the need for someone in a gateway or in the back end that does the application for sensor networking that can continuously have to poll the device, not knowing whether it has anything interesting to say. And then in pure state synchronization, there are lots of examples of things that need three-way or even more than three-way handshakes in order to make things work. And constructing multi-way handshakes out of sets of two-way handshakes is complicated and error-prone. So if you want to push data, and lots of applications conceptually want to push data, this is not terribly convenient using a pull-based ICN procedure, right? Because the interest message which requests the data tends to get big. And all of our assumptions about other aspects of doing any of this at the network layer is that your request messages have to be small for congestion control and amount of state held in the network reasons. So trying to push data in an interest message sort of messes up all of those considerations. And if you want something that's even minimally secure, you need to sign interests in order for the push data to be believed. And this has other bad effects. It makes the interest messages even bigger. And then there's a computational cost at the other end in order to validate the signature. And this can result in a computational denial of service attack against the producers. And of course, wasted bandwidth if you make requests and then they can't be satisfied. So there's a variety of reasons for this. So there's a bunch of other reasons, but I want to really get to the core of this. So I'm going to let you sort of read this offline in terms of a bunch of the other reasons. So I'm going to skip through this very quickly. So our design overview is to be able to utilize the forwarder state that is established in the forward direction from the consumer to the producer in order to use that state to allow information to be propagated back toward the consumer using state that you've already established. And we do this with something called reflexive names. These are names that are asserted by the consumer for the producer to construct effectively an interest message going back toward the consumer. So you can construct multi-way exchanges out of the initial exchange. So we utilize that forwarder state, not just for being able to return a data message, but also for processing these reflexive interests to flow from the producer back to the consumer. So we have a scheme for these prefixes, how you construct those names, and the forwarder mechanisms for routing them back from the producer toward the consumer and allowing it to couple the state together. So if you just want to look conceptually, the protocol has a lot more in it than what this simple slide is, but the idea here is you can construct multi-way exchanges. The first initiation of that exchange we call a trigger interest because it's potentially triggering more exchanges in the opposite direction. And then we have reflexive interests returning data back in the other way. There could be multiple of these, and then the total state gets terminated with the final response in what's called the trigger data that comes back at the end. So I'm going to skip the rest of this, and then I'll turn it over to Hitoshi to go and talk about the details of what we've designed and how the protocol specification has evolved since its initial introduction a few years ago. Thanks. Oh, questions before Hitoshi takes over? Do we have anybody in the queue?
No.
Okay, thank you.
Okay, thank you. So from here, I'd like to explain some detailed specification, and now the motivation and backgrounds are explained by Dave. So from here, I'd like to explain the terminology and definitions. So they've already mentioned about reflexive interest, trigger interest, and so on. So just I'd like to show again that trigger interest is triggering the request from the consumer to the producer, and then after producer receives the trigger interest, then he will see will send back another request named reflexive interest, and then to reply the reflexive interest, consumer send a push data toward the publishers. So to indicate this kind of message exchanges, so we newly defined the TLB, which is a reflexive name prefix, RNP TLB. So inside the RNP TLB, there is a name identified push data, which is a reflexive name segment. So these are the main terminology and definitions. So this is a little bit detailed explanation about the message. So note that from here, I'd like to mention especially for the CCNX implementation, but I believe that NDN extension would be identical to the CCNX schema. So I believe. So the trigger interest and trigger data message format is like this. So for example, we have a full name. The name is ABCD/EFG/RNP value. So RNP value itself is a random value. Let's say it's a random value, and that can be assigned by UUID. So if we use a UID, then the random value can be 128 bit. And that one is already mentioned in the RFC, the different RFC. So there is no special packet format. So actually this one is encoded in a regular interest message. So packet type itself is ordinary interest message. So the packet type is interest, and from the T name, so this is a name TLB. So there is a name segment. We have a two name segment. Then we append the new reflexive name TLB here. So this value is RNP value or name segment name segment. So this is a trigger interest. So after this sent to the publisher, then publisher just remove the topmost part. Oh, sorry. Oh. So these name segments. So after publisher receives this interest message, just remove name segment, and then the packet is started from reflexive name TLB. So this is a reflexive interest packet format. Then the full name itself is this kind of random value. So the forwarder can distinguish that this is a reflexive interest because it started from a newly defined reflexive name TLB. So this is a simple flows for exchanging the trigger interest and reflexive interest. At first, consumer sends a trigger interest with the newly defined message format, which is in the reflexive name TLB. So reflexive trigger interest is sent to toward the publisher. To make publisher send reflexive interest, and for the registers TI's full name in his PIT, and we call it TI PIT, and the reflexive name segment is also registers as a RIP dummy. So this kind of naming is, any name is fine. So just I'm explaining our CFOR's implementation, so you can change the name. So this is just the implementation specification. It's not a protocol specification, so you don't need to care so much about this kind of name. So the forwarder received after he received the packet, he registered TI PIT and PIT, the RIP dummy, and was TI to producer. And the producer sends reflexive interest whose high order name segment is the reflexive name segment specified in RNP TLB, like this. And for the registers reflexive name segment, we call the RI PIT, just without dummy. So dummy PIT is not used for other PIT, as a ordinary PIT entry. So this is just something like a note. So after the forwarder receives the reflexive interest, then he can copy the RI PIT dummy entry inside his regular PIT entry and where's RI without referring its field. So this is an important part. So he doesn't need to care the name or name itself to forward this reflexive interest to consumer, because RIP dummy is already mentioned in his PIT entry. And then reflexive interest is forwarded to consumer and reply the data, which means that he pushed data as a reflexive data sent toward the producer, and the PIT entry will be used to forward this RD. And after producer receives the RD, then if he thinks that this is the end of the pushing data, then he sends to the trigger data to terminate this trigger interest, reflexive interest communication. And then after he received the trigger data, then he just clean up the corresponding PIT entry and then terminate the session. So this is a more specific part for the PIT entries management. So this is a conventional interest forwarding. So this is just a regular interest. So he sends an interest, and then he refers the FIB entry and the registered PIT entry, and then forward to the interest, and like this. So this is a ordinary interest forwarding flows. For the reflexive forwarding operation, at first the consumer sends the trigger interest, and the full name is, let's say, abc.com/RNPID, and the RNPID can be any kind of random value. So for this example, we use a UID to generate a random value. So RNPID is like this. So this is a full name for the trigger interest, and then the trigger interest is sent to toward the producer, and when he received the trigger interest, he registered the PIT dummy, like PIT dummy entry. This RIP dummy is just a note, as I said. It's not used for the forwarding the RMP, forwarding the RI or RD. So this is just a memo, and then forward it to toward the producer. And then producer send back to the reflexive interest to consumers, and then he send it back to the reflexive interest, and then this guy, he already know the RMP ID as a memo, so he can just copy this entry into the actual forwarding entry used for the forwarding the reflexive interest inside the PIT. So previously, the Mark already mentioned about the chunking draft, and we can support also chunking. So if the contents can be chunked with a multiple chunk, then the same RMP ID can be used for the different chunk number, and the RMP ID can be just referred to forward each chunk interest and chunk data. Okay, so I briefly explained the implementation procedure and the PIT management structure. So still, but of course, we have a lot of open issues and to-dos. For example, multiple RMP TLD can be packing into a single RI or not. So if allowed, how to deal with them, multiple RIs should be independently sent or not. This kind of part is a little bit headache. Well, we should discuss much more about this part. And trigger data can be cached or not. If trigger data is cached, RI reflexive intent cannot be reached to the publisher because the trigger interest is stopped at the inside the network, and then trigger data is returned. So this kind of procedure is allowed or not. This kind of part also we need to consider and address. And what if multiple publisher receives TI trigger interest via multipass route? Of course, CCNX or NDN can support multipass route. So the trigger data itself can be sent toward the multiple publishers. In that case, only the publisher who sent back the first TD can be terminated at the session, and the other receiver who doesn't send the TD or who doesn't receive RI cannot complete or cannot finalize the trigger data's, reflexive data's reception. So this, the first, so in other words, the first ID, first TD received removes TI-PIT and thus halts subsequent RD receptions. And how RD can be securely transmitted. This kind of security part should be also considered. So please read and comment on the spec in general, not just on the specific issue and the authors are working through. We have an in-progress implementation on C4. So please do some experiments for any use case. We will identify the new ones you can think of. Particularly, we are interested in phone home use case for IoT devices, especially low-end sensors, web services, distributed computing, and so on. Okay, so that's all. Thank you.
Great. Thank you, Hitoshi. Can you go back to the previous slide? Right. So these are kind of questions that could be discussed more in the group. So like for the first one, multiple RMP TLVs. So our thinking so far has been that if you want to make the producer fetch like multiple values, then that could be a case for a flick manifest as well, right? So sorry. So if you want to achieve like if you want to have the producer fetching multiple values from the consumer, then that could be a use case for a flick manifest as well. But of course, there may be different views on that. For the second one, caching or not, so well, we had this use case for remote method invocation, and so in that scenario, assuming you have like idempotent operations that where you don't have any additional side effect from executing the same request multiple times, it makes a lot of sense to have the TD cached so that actually so it doesn't have to act on it again. So there our thinking has been that this should just be like any other content object should be cacheable. So just what we discussed so far. Right?
Yeah. Thank you.
What is the next?
Rob Van Meter, Keio University. Dirk and Dave both need to be shorter so they can reach that microphone on the table there. So this is not a technical question. It's more sort of a where are we with the documentation question. Both in Dirk's share of the presentation and in Hitoshi's, there were several diagrams, including packet formats and messaging sequence. And I haven't looked at the draft before, but I just scrolled through it, and it doesn't look like there are enough figures and enough details to match what's in the slides. Do you think? Where do you think you are relative to the information you had in the slides versus in the draft?
So what's in the draft is basically what you would put in any IETF protocol document, which means there's type registrations and pointers back to the basic CCNS specs. So what you're looking for, I think you would find in the already published RFCs. That would have all the, this is just what would be added to the existing protocol documents.
Okay.
Why don't you look at them and make some suggestions as to what we should include? Sorry to turn the question around on you, but
no, it's fine. I'm coming into this mostly cold. I don't have my head buried in this like the rest of you.
yeah, well, anybody who's reading it for the first time is a very valuable reader, right? Because they won't be conditioned on cached state of having read it before. Right. So if there's something that needs to be said that isn't said, you're exactly the kind of person we need to review this to give us some guidance as to what we're missing. So
Okay.
Thank you.
The first one that caught my eye was literally the packet format. I'm not sure that's where that's documented properly.
Yeah, everything but the new fields is documented properly in the originally published RFCs. But
Okay. Thanks.
the new fields are obviously not. Christian.
Yeah, Christian, I'm just sorry if I'm missing a bit of context because I'm a bit of a tourist here. When you go to slide 8, those RNP IDs, are they constant from like in between each forwarder, or is that something where a forwarder like might interfere and like might extend the RNP ID so that it can start carrying less state? Or is that literally same RNP ID that is end-to-end constant?
Sorry, I tried to just scroll that, so I couldn't.
So the RNP ID on the left and right, is that really literally the same value all the time? Okay.
This one?
Yep. This is the right one.
This one is the same for the single stream, but of course that can be changeable or must be changed actually.
Yeah.
Yeah. So this one is can be kept as a same value if let's say so I try. Okay, now works. Oh yes. For example, the content. So this is a content name, like a content name, but it's a temporary content name. So if the content is consists of multiple chunks, then this ID can be used again and again. But if we change the different content, that RNP ID should be or must be changed.
Thank you.
Thank you, Christian.
And okay, so I like just to reply to the loudest question. So did you check the latest draft or the previous? I think the latest draft I mentioned. Of course, it's ASCII figure, so it's not like this. But I think it's almost the same information as inside the latest draft.
I was going straight out of the agenda from the data tracker. So assuming you linked that correctly, then yeah, it's the latest draft.
Okay, so it should be the
Yeah.
latest one.
Yeah, there was one in the draft. It looks, if I remember right, there was one with what's the right term? So consumer forwarder or producer with one forwarder, but I don't think there was anything with two forwarders in it.
No.
And I don't have enough in my
no.
head. I don't have enough in my head to know whether or not that's an important
Just
piece of
single forward.
exposition that should go into the draft as here's a clarifying example, or if you can expect that the intelligent implementers can infer that and make this work from that. I'm not sure.
Okay.
Good point. Okay, yeah, thanks so much, Hitoshi.
Thank you.
Great work. And we're moving on to the metaverse.
Everyone put on your headsets, please.
Okay, let me start. Hello, this is Jung Ah-hong from E3 in Korea. And this is the very first draft on the ICN challenges for Metaverse platform interoperability. And the object of this draft is to explore how ICN can address the key challenges for Metaverse platform interoperability. And also the goal of this draft is to provide the foundation for ICN-based interoperability in Metaverse, and also promote the further IETF or IRTF collaborations in the future. This is the table of content. We provide briefly about what is the Metaverse platform interoperability at the beginning, and then provides a couple of service scenarios for that, and then provides the why ICN is for Metaverse platform interoperability. And then section 5 is the ICN challenges for the Metaverse interoperability. And then we provide a couple of proposed solutions in section 6. And the concept of the Metaverse has been around for a while. I'm sure like beginning of the 2020s, it has been emerging for now. And there are many concepts, and there are many in different domains use different definitions. But as far as I know, currently there's no unique definition so far. So I just brought one of the definition from the ITU, which was developed last December from the focus group on Metaverse. What it was is the Metaverse is an interactive ecosystem of the virtual worlds, offering the immersive experiences to users that modify pre-existing and create a new value from economic, environment, social, and cultural perspectives. A Metaverse can be virtual, augmented, and representative of or associate with the physical world. And then, so why we need the interoperability? So the Metaverse platforms are developed by different companies with its own set of the rules and protocols and access, which creates a fragmented Metaverse ecosystem. So if the Metaverse platform interoperability is possible, then it can allow the user to interact and transfer assets and share the experience seamlessly across the platforms. So, but the current network with the host-based network has a couple of has some limits to support this interoperability. So we believe that ICN can offer the ideal network for the cross-platform connectivity. This is just simple use cases for Metaverse platform interoperability, but this is not the real service because the interoperability is not available for now. But for exhibition, shopping, co-working is already available services in the current platform for in individual platforms. But here we try to describe the use cases across the platform, different platforms. So why ICN is for Metaverse platform interoperability. So we know that what is the ICN? The ICN focuses on the content retrieval by name rather than the server location. And also it enables efficient, flexible data access across the platforms, making it a strong candidate for Metaverse. So there are a couple of benefits of the ICN for Metaverse. The first one is the content-based access, and then the ICN can reduce the dependency from the central server, and also the ICN can provide the security and efficiency for the real-time cross-platform interactions. And now we present a couple of the ICN features which can support the Metaverse platform interoperabilities. First one is content-centric communication. In ICN, the data is accessed by name, not the location. So it can simplify the asset sharing across the platforms. And then the key feature is the in-network caching in ICN, which stores the frequently accessed data close to the user. So it can reduce the latency, allowing instant access to shared virtual asset across the platforms. And then the seamless broadcast and broadcast can support the shared experience like events by delivering contents to all participants in real time. Next is the security and data integrity. The ICN can protect the digital assets and ensures the privacy as a move across the platforms. And also the ICN's named data object can ensure the asset management and rights tracking for cross-platform interactions. And the ICN also can ensure the smooth interaction as more users and platforms connect. And ICN decouples context from the location, so it can make the asset accessible across the platforms. Although there are lots of good ICN features for the Metaverse Closed platform, but we have a couple of challenges to improve, to implement. So first one is scalability. So the millions of users will be interacted in real time. So the managing large data volume and simultaneous interactions across platform has to be addressed. And also for real-time interaction, such as avatar movement and voice communication, achieve the ultra-low latency is also important and challenging. And also the ensuring secure content distribution across the platform is also challenging, and also supporting complex ownership structures with permissions and usage rights for asset across platform is also challenging. These are just proposing that we think this could be solved the challenges, but this is not the right solution, but we are just suggesting. the further scalability, we can use the adaptive caching strategy, which can optimize the caching to reduce the latency and keep the contents readily available near to user. And also we can leverage the multicast and the broadcast, so we can to improve the content distribution for real time. And also we can use the enhanced security layers, which implement the advanced encryption and authentication and access control to protect digital assets and sensitive data. And then we also enhance the named data object to manage the ownership and permissions and uses the right for asset in the metaverse. And this is all I have for today. And there are a couple of side meetings for metaverse in IETF before. Over there was a couple of discussion about the ICN and the metaverse. So I think the metaverse is a kind of interest word or technology in IETF. So I thought it's good to have a draft in the ICNRG. So please contact me if you are interested in this draft as a co-authors. Yeah. Any questions or comments?
Questions, comments?
Adrian from Taiwan Telecom. Do you have other for a plan to implement the or to solve the interoperability issue for the metaverse? Do you have other for a plan after a side meeting or other?
We are not. For now, we are not having a plan to implement to use the ICN for yeah. But we are like we are developing a service scenarios actually in ITUT as well. So maybe we can collaborate with ITUT work and the IETF work in the future.
Okay. Yeah. Thanks for bringing this to us. Let's move on. Thanks, Jonah.
Thank you.
Yes, please send comments on the mailing list as that's our normal communication channel.
And now we are continuing with microservice communication.
Yeah, I'm Adrian from Taiwan Telecom. So here we just describe some consideration for the evaluation of the ICNRG work into the IETF. I think maybe related to some topic in previous prior topic. So first I will introduce the requirement for our consideration, requirement from the distributed microservice from the cloud. And I will also give some brief introduction of the mesh, service mesh. And I will introduce briefly our previous proposal for the distributed architecture for the service microservice communication and the consideration for the future work. So first, I want to introduce the requirement from the distributed microservice from the cloud. You know, we call microservice is some small independent unit of the application, and such a component used mainly in the cloud service. And the general microservice communication have the following steps. First is the service registration and the service discovery and the service measurement and service schedule. This is very similar with our action in the IP network. For example, the prefix registration, prefix discovery, and the prefix traffic measurement, traffic schedule. This is the requirement from the distributed microservice from the cloud. And so how to currently such requirements are solved by the infrastructure called the service mesh. So here just want to introduce what is the service mesh. So the service mesh is a dedicated infrastructure layer for handling the service-to-service communication. A service mesh can provide such capability like traffic management and security and observability. Currently, there is one open source software to implement such function. It is called the IETF. And below is the evolution history of the service mesh. Firstly, in first stage, for the communication between different microservices, all the microservices must finish all the components for the communication. And in the second stage, such common module are extracted and can be used by different service. And currently, such common module are located in different components. They call it the sidecar to accomplish the common communication functions that's required by the Microsoft communication. And so the aim of the service mesh is there are several functions. First is the service discovery. Second is the load balance, and the third is security, and the fourth is the observability, and the final is the traffic control. Currently, the service mesh is implemented in the central control manner. That is, all the policy are managed by one central controller, and they will download the such traffic policy to every proxies. And in the large deployment of the service mesh, every proxy can connect it together and form one service mesh topology, like this illustrated in this diagram. So this is a kind of solution for the service mesh that meets the requirement from the communication of the microservice communication. But there are some challenges for the such solutions, because the service mesh is located near the microservices, so it adds complexity. So as I mentioned, it introduces the additional component and some complexity to the system. And so, for example, the sidecar proxy and the control plane component. So, and also the controller need to management many configuration and policies. So I think this might increase the learning curve for team and require new skill to expertise to manage the service mesh effectively. The second challenge is the performance overhead, because the user for the sidecar proxy to intercept and manage traffic between the microservice, and so it will introduce some latency and additional resource consumption. And the last is the maturity and the adoptions. Because all service mesh technology has been gained traction in recent years, and many cloud products are using such information, but they are still relatively new compared to the traditional networking and management solution. Because as I introduced just now, that the requirement from the service communication is very similar with the traffic, with host and host communication in our IP network. So I think the for the newer organization, maybe they encounter some challenge to incorporate the service mesh into their application service. So here is the bottom of the diagram illustrated the challenge for the current service mesh solutions. So we have provided the distributed architecture for the microservice community. As I introduced, the currently service mesh is implemented in the central mode. So all the policies are downloaded from a controller. We think it is not not strong enough to incorporate all requirements in future. So here is our company's motivation. So consideration about challenge, and China has one cloud company, and our cloud service also increase every year. So we require one innovation solution to adapt the continuous growth demand of the service, microservice communication, and also we can requirement such solution can offer the end-to-end service telemetry, so we can assure the service communication performance, and we want to such solution to provide robust mechanism to ensure the high ability and performance of a critical microservice, and the solution must provide the flexible schedule capability. And also we want to such solution support the information-centric communication, because there are other services that can make use of the such infrastructures. So here is just some summarize some key character for the distributed solution for the mixed communication. The first is we want to the solution is content-centric, and also the decentralized, that is the distributed solutions. And so we can also the solution provide some dynamic resource allocation, and it can be scalability and can be used very flexibility. So we are now how to finish such work. So there are some consideration for doing such work within the IETF. So what's the reason we want to especially currently we want to establish a new working group within IETF to industrialize the ICN work. So we know IETF is the venue to industrial technology and the latest specifications, and many experts from the vendor are gathering at IETF. And I think ICNRG and ICN work has been done for several years, for about 10 years. But we all try to find some killer application to industrialize the ICN side. And I think the service mesh is one trigger application to initiate the new working group to accomplish the distributed Microsoft communication. So to establish the such work within the IETF, we want to revisit the published RFC within our ICNRG, and to use RFC to and try to find some gap between the existing standard work and the implement requirement from the vendors. Currently, we think that such new group should be located in the interior. Here is the aim of the new working group within IETF. So first, we want to analyze and define the requirement of the distributed service communication, especially in the kind of function that they provide the service mesh. I think the meta communication is also one example to initiate such work within the IETF. And the second is we want to define the architecture of the distributed service communication. And after doing this work, we want to extend the control plane to facilitate the distribution of service name. You know, we are as a service expert from the service provider. We are very familiar with the control plane to distribute the prefix information. I think we can utilize the current control plane to distribute the service name information to the within the network node. And we want to define some new fault plane format or directly over the Ethernet, not the IP, and also their behaviors to achieve the content-based forwarding, and also the KTX. And after it, we want to define some northbound management model to control the developer service traffic engineer policies to achieve some end-to-end QoS assurance and some other the OEM tools. So this is the aim of the new working group within IETF. So here is the expect timeline for the IETF and this WG. So we have introduced, we have invite some famous cloud service provider in China, for example, Ali, and some famous device vendor, some, for example, the Huawei and ZT and H3C to work such aim with us together. So firstly, we want to investigate the current implication and the challenge of the service mesh, especially the open source ISO, and this is the service mesh. And also we want to consider other killer applications, the requirement from other killer applications. Based on this requirement, we want to define the architecture of the distributed service mesh to carry the such application. And after that, we want to collaborate with the industry and also the research and development of the to define and implement the new type of the router we call the content-based service router. After if we have implemented some some new type of service router, we can do some field test for ICN-based DMC or ICN-based some other killer application. The ultimate goal is to facilitate the development of the CS we call the content-based service network. So the target plan for the content-based network is we want to develop a service-oriented network architecture to simplify the enterprise cloud communication, advancing cloud-native application and make service across the industry such as e-commerce and live streaming. So we want to cooperate with the cloud provider and some content provider and also the other telecom operator to put for this work, and also another important partner is the vendors, because we want to define and implement such new type router. Such project we want to first we want to implement the service mesh that enable unified service discovery and authentication and traffic control and fault management. And we think such infrastructure can support natively make the service communication and also the multicast and also the CDN service. So
Arjun, you have 1 more minute. We have
okay. So such infrastructure can simply our infrastructure for the network and the cloud integrations. Okay. So we are also want to encourage the expert from the ICNRG to participate in our work to accomplish such aim. Okay, thank you.
Okay, can we do questions quickly?
Yeah, thank you. Daniel Huang, ZTE. I think it could be a good idea to bring some work of ICNRG to IETF for the microservice interconnection because there's obviously some benefits, but we have to keep in mind that we need to keep a very delicate balance between the benefit and cost. So, and another point, I think we need another name for microservices if we design content-based microservices, because it is as it is, because it will be far more aligned with the underlying network.
Okay.
As I mean, so yeah. Thank you.
Okay, thank you.
Okay, final question by Rio.
Rio Yanagida from University of Glasgow. Are you soliciting for any work from us? First of all, thank you for bringing this sort of like use case of the ICN. Do you think it's ready to be brought into IETF already? Or I feel like maybe it might warrant a bit more sort of research questions, perhaps to be laid out to the IRTF, like ICNRG first, and then do a bit more work before even thinking about IETF, in my opinion. What do you think about that?
Currently, I think the component to achieve such aim has been ready. So I think it is time to implement this within the IETF. Certainly, we need to some more research work to form such a new working group. We will try to have several both meetings to discuss the how to design what is the requirement and what is the overall architecture, and so if there are enough interest to accomplish such work, I think it is time to establish a new working group to accomplish this.
Thank you.
Okay, so yeah, the timing is certainly quite ambitious. So I can understand that people are quite interested in that. Please ask your question on the mail list, and then Arjun and colleagues are happy to answer. I think so many people would maybe agree that intuitively there is quite some potential, but there are maybe also many open questions. And yeah, if you want to discuss this more, please use our mail list. Thank you very much.
You can also send mail to me for further discussion.
And so this brings us almost to the end. Just a quick ideas for potential future meetings. So some of the ICN folk will be at ACM Connect in December in LA. If you are around and you are interested to discuss or to meet, just maybe please contact me or just send on list. There is also IETF 122 in Bangkok coming up. Please do think about potential contributions, so new research ideas or research results. I might organize a pre-IETF event in Hong Kong, possibly on the Thursday before the IETF. If enough ICN people are around, we could also focus some discussions on ICN. Please talk to me or use the mail list. Thanks very much for coming to the meeting. Especially thanks to Rio and Rod for taking notes. Much appreciated, and hope to see you again soon.
I just have one thing to add, which is that we're making a lot of progress thanks to Hitoshi and his team at NICT on the C4 implementation that will be hopefully ready for people to actually build applications against relatively soon. So we might consider doing some kind of hackathon at either an interim next IETF or maybe in association with Connext or something that Dirk can host. So start thinking about putting some cool applications on top of this infrastructure, because that's one of the things that's been somewhat lacking in the community over a number of years. Something involving metaverse stuff, I think, might actually generate a lot of interest in the wider community. And again, thanks everybody for coming and participating.